Welcome back, students. So now we're going to discuss the permutation combination concept 2. So yesterday, the last recording video, I had given some of the questions in permutation and combination. So now the next level of questions. Right, let's start with this. The value of 74p2. 74p2. How can we write? There is only two places, but 74. So 74 into 73. This is the easiest way. Instead of using NPR formula, n factorial divided by n minus r factorial, you can write like this. Okay. So 74 into 73 is the answer. 4 into 3. Take the unit digit. 4 times 3 is 12. So my answer will be ending with 12. If you had doubt, you can just check this. Okay. If none of this is not given, directly I can take 5402 as the answer. Right. And next question, 74C2. Here it was combination. So combination means it had repetition. Repetition means over 1 into 2. This is combination. So 74 into 73 over 1 into 2. Okay, whatever the answer you got, 5402 divided by 2, half of that is the answer. So this is what the right answer. Let's move to the next question. How many words can be formed by rearranging the letters of the word accent such that A and T occupies the first and last position respectively? Right. So in this concept, we're going to take the word accent. Right? Okay. A should be at the first and T should occupy at the last place. So how can we write the equation? In permutation, one place is allocated for one letter, that is A. First place is allocated for the first letter. And last place is allocated for T. So whatever the condition is given, first write answer for that. Then place the remaining letters. So how many letters are there? 1, 2, 3, 4. 4 letters and 4 places there. Our answer will be 1 into 4 factorial. 4 factorial is the answer. That is nothing but 24. 4 factorial only given here. Next question. Right. In how many ways can 7 Indians, 5 Pakistanis and 6 Dutch people be seated in a row so that all persons of the same nationality sit together? So this is one nationality. These persons are Pakistanis and Dutch. So everything is different nation, right? Wherever they sit, they will be a gang. Always they will sit with each other. So 1, 2, 3. They can mingle here. This 7 person can come to here. This 6 person can come to here. This person can come to here. So 3 factorial. Out of 3, in this first one, they had 7 members. They can interchange each other, right? The 7 people can interchange themselves, not with Pakistanis, not with Dutch people. Okay, so Indians are mingled with Indians. So 7 factorial, then 5 factorial, then 6 factorial. This is what the right answer. Where is the answer? Yeah, option C is the right answer. Next question. In how many ways can 4 Indians and 4 Nepalis people be seated around a round table so that no 2 Indians are adjacent position? So if they are talking about Indians, no 2 Indians should sit together, means you need to check the Nepalis first. I want to give one example for this concept, then only you will understand this. Okay, so don't take this as a round table. Okay, just take a row. There are 4 Indians and 4 Nepalis. No 2 Indians should sit together, means first we need to allocate the Nepalis first and allocate Indians chairs first, then allow Indians to sit. Okay, if you allocated alternative places and send all the Indians to the room, means definitely there is no other way. Look at this, 4 Nepalis. So first Nepali N1, second Nepali N2, third Nepali N3, and fourth Nepali N4. Let name like this. Okay. Now I seated all the Nepalis first, and I'm going to put chair in between the Nepalis. Okay. So this is first one. This is second chair, third chair, fourth chair, and fifth chair. Okay, now in this 5 chair, I get seated. Now I allow Indians to select whatever chair you want. Okay, look at this. First 4 Nepalis are seated. So 4P4. Next, I am putting chairs for Indians. Okay, in alternate place, because here no 2 Indians should sit together. So totally 5 chairs are there, but we had only 4 Indians. If these 4 chairs are seated, means this will be empty, no issues. You can take the chair afterwards. This is how the concept was. But here there is one more concept, that is they are seated in round table. So if it is a circular permutation, we had formula n minus 1 factorial. If there are totally 6 persons, means 6 minus 1 factorial, 5 factorial. If totally there are 10 persons, means 10 minus 1, 9 factorial is the answer for circle. Okay, so again, now we take a round table. Now, first we going to seat Nepalis first, as usual. There are 4 Nepalis, right? So 1, 2, 3, 4. 4 Nepalis I am going to seat it first. But what is the formula? N minus 1. So 4 minus 1 factorial. So 4 minus 1 factorial is 3 factorial. So I plotted all the 4 Nepalis first. Now, listen. Now, after this, don't go for this formula. Now I'm going to look at that. How many alternate places are there? So there are 4 alternate places, right? So 1, 2, 3, 4 Nepalis are placed and 4 alternate places are there. In this 4 alternate place, I got 4 Indians. So they can select whatever chair they want. So 4 Indians and 4 chairs are there. So 4 factorial. 3 factorial into 4 factorial is the answer. Only first time we need to use n minus 1 factorial. Okay, once it was plotted, then don't go for this. How many chairs, how many persons? As usual, you can write the answer. So 3 factorial into 4 factorial. If you guys are not aware of this concept, please check permutation and combination videos. Concept videos I had posted already. Okay, so here I am come to solve the problems. So directly using the formulas, I solved it. Okay, even more, if you had any doubts, just put it in the comment box. I will give you the definition afterwards. Right? Look at this. Ramesh, Abhijit, Ajay are eligible for the captain of the cricket team. Then 4 persons, Sai, John, Shishar and Nitin are eligible for co-captain. How many possible outcomes are there for choosing a captain and co-captain? So totally there are 3 persons are waiting for 1 captain. So choose any 1 person out of this 3 for captain post. And 4 persons are waiting for co-captain. Okay, out of 4 I am going to select anyone. So our answer will be 12. 12 is the right answer. Next question. In how many different ways can the letters of the word corporation be arranged so that the vowels always came together? Okay, so the vowels always come together. What are the vowels here? O, O, A, I, O. O, O, A, I, O. So it should be always together, means find it. So how many consonants are there? Apart from vowels, consonants are 1, 2, 3, 4, 5 and 6 plus this one word. I make this as a 1 letter. Okay, so 6 plus 1, 7. So 7 factorial. In this, that 7th letter had how many letters? 1, 2, 3, 4, 5. So 5 factorial. Next, how many repetitions are there? Look at this, 3 O's are there. So 3 factorial. How many R's are there? 2 R's. So 2 factorial. This is what the answer. Okay. So what is 7 factorial value? 7 factorial value is 5040. 5 factorial value is what? 120. 3 factorial is 6. 2 factorial is 2. Cancel this number. 60 and 6 cancel. You will get 10. 5040 into 10. 50400. That's what the right answer. Okay. Next one. How many three-digit numbers can be formed from the digits is given which are divisible by 5 and none of the digits is repeated. I want three-digit number and it should be divisible by 5. What is the nature of 5 table or multiple of 5? So the last number should be 0 or 5. Then the whole number will be divisible by 5. Right? So in the given numbers, there is no 0. Only 5 is there. So I take this 5 and I'm going to write here. Okay. So one number was plotted in the last place. Okay. Then remaining I had 2 places. Apart from 5, 1, 2, 3, 4, 5 digits are there. So 5 P, how many places? 2 places. So answer is 5 into 4 into 1. That is 20. There are 20 different ways are there. Is it clear? The 5 is a single digit. So that digit should be plotted always here. Okay, the remaining numbers will be placed in different ways. Right. Next one. A committee is to be formed comprising 7 members. I need 7 members committee. Okay, in this majority should be men and at least one woman should be selected. So how many men are there? 9 men. Okay, and women are 6. How many ways can this be done? This is what the question. Let's start with this. Whenever the word at least, at most, more than, less than, minimum, maximum, majority, all these words is given, try to make one tabular column. It helps you to write all the combination. Otherwise, you will fail to write any one or two combinations. Okay. So men and women, they want at least one woman. So if I select one woman, I need to select 6 men because totally I want only 7 members. If I select 2 women, I need to select 5 men. If I select 3 women, I need to select 4 men. If I select 4 women, I need to select 3 men, but this is not majority. Majority should be men, not women. So stop here itself. So now I'm going to write the combinations. So that is why I told you that write tabular column like this. It helps you to, without failing, all the combinations you can write. Okay. So out of 9 men, I am going to select 6. Right? Into out of 6 women, we're going to select 1 woman. This is the first one. Right? And let's move to the second. So either or this or next combination. So put plus symbol. Out of 9, I'm going to select 5. And out of 6, I'm going to select 2. Plus. Next, go to the next combination. So or. Out of 9, I'm going to select 4. And out of 6, I'm going to select 3. So we need to write answers for all these numbers. Okay, so 9C6, we can write 9 minus 6 is what? 9C4. Okay, into 6C1 is nothing but 6 plus 9C5. 9 minus 5 is 9C4 into 6C2 is nothing but 15 plus 9C4. Right as it is, whatever the answer come for this, right here itself, here also. Okay, 6C3, 6 into 5 into 4, 1 into 2 into 3. So cancel 5 into 4 times 20. So just solve this, you will get the answer. And what is the answer for 9th sum? Yeah, right. So answer is option C. Okay, so I don't want to take much time for solving this. You can do it. Concept is this. Right, next question. In an examination, 10 questions are to be answered, choosing at least 4 from each part A and B. So there are 2 parts A and B. Okay, totally we need to answer for 10 questions. Okay, if there are 6 questions in part A has 6 questions and part B has 7 questions. This is what given. Okay, how many ways can these 10 questions be answered? Okay, and they say that one word at least 4. So I'm going to put a tabular column A and B. Okay, how many questions we're going to take from A and B? At least we need to complete 4 questions. So if I take 4 questions, totally I need 10 questions. So here in part B, I need to write 6. If I write 5 questions from B also, I need to attend 5 questions. If I write 6 questions, here I need to write 4. If I write 3, this is not possible because at least I need to attend 4 questions. Okay, so this is the 3 combinations. So out of 6, I'm going to attend 4. Into out of 7, I'm going to attend 6. This is the first combination. Plus out of 6, I'm going to attend 5 questions, and out of 7, I'm going to attend 5. Plus, out of 6, attend all the 6 questions, and out of 7, write 4 questions. So, this is what the answer. You will get 266 as the correct answer. Check. Do it and check whether you get 266 or not. Okay. Right. Next question. If we permute 5 letters of the word lemon, so if you permute lemon, 5 letters, 5 places, so 5 factorial is the answer that is given. 5 factorial ways. But the question is, in how many words vowels do not come together? So what are all the vowels here? One is E, and another one is M. Okay, so it should not come together. So I don't know how to write it should not come together. So better we can find if they come together. So leave this. If they come together, what is the answer? I make these two as one letter. Okay, so 1, 2, 3, and this one 4. 4 factorial. In that 4 factorial, fourth letter had 2 letters. Okay, so into 2 factorial. This is the answer for vowels came together. So now, from the overall answer that is given here, from the overall answer, if I subtract this answer out of 5 factorial, if I subtract this answer, I will get not come together. Okay, what is 5 factorial? 120. 4 factorial? 24 into 2. Right? So that is nothing but 48, 120. Answer is 72. Easy. Next question. 5 friends, Megha, Meghna, Mehak, Menaka and Meenakshi, are to be seated on a round table such that Megha never sits next to Meghna. This is the main thing. Okay. Thank God only one girl is like this. Sometimes all girls will be not sitting with their friends, means it's very difficult for us. Anyway, so in this, we had a round table formula n minus 1 factorial, but here there is no use for this. Why? Because only for the first person who choose the chair, we going to use this formula. But here some conditions are given, so no need to worry about the person who select the first chair. Look at this. If how many persons? 5 persons are there. So now I'm going to put 5 chairs for this 5 person. Okay. First person, second person, third person, fourth person, fifth person. I put 5 chairs. Now, if 5 persons going to select this 5 chair, means I can use this. Okay, 5 minus 1, 4 factorial is the answer. But there is a condition. Megha never sit next to Meghna. So, first is place the Meghna. That is the right choice. So, if Meghna selected this, definitely Megha will never select these 2 chairs. Okay, she will never select this. So, Megha had only 2 options. Either she need to choose this or that. Okay, so out of these 2 chairs, Megha will select any one. Before that, I had placed Meghna, right? So I will write 1P1. This is for Meghna. And 2P1 is for Megha, because only out of these 2, Megha will select any one. Okay. So how much chairs are remaining? 2 chairs. In these 2 chairs, I am going to seek the remaining 2 person, that is Mehak. Yes, Megha is seated, Meghna is seated. So remaining we had 3 chairs. Any one of these chair will be Megha will sit. So remaining 3 chairs, 3 persons will be seated. They can sit wherever they want. So 1 into 2 into 3 factorial. What is 3 factorial? 3 into 2 into 2. Answer is 12. But that is not given as the answer. How many ways it is possible? 4 factorial is training for 3 factorial. Yeah, 3 factorial into 2. Here there's an answer. Yes. Oh my gosh, I can solve it. Right. Next question. In how many ways can the team members be arranged for the team picture if all the males are always together and if the team comprises of 7 males and 6 female? Look at this, 7 male and 6 female are there. Okay. And they want to create a team. That doesn't say that how many members they want to create a team. So 7 plus 6 is 13. So 13 member is a team. Over, I'm going to fill all the 13 numbers for a team, make a team. But there is a condition. Men will be always together. So if it is always together means what we will do, make this as 1. Okay, so 6 plus 1 is what, 7 factorial. In this 7th one there are 7 members inside, so 7 factorial. They can interchange each other with themselves. So the 7 factorial into 7 factorial is the right answer. Okay, next question. In how many ways can 4 ladies and 4 men from 2 mixed double teams for a tennis match? So, mixed double teams means what? 1 male and 1 female. Okay, for one team. So, likewise, I need another male and female for another team. So, this is team 1 and this is team 2. So out of 4 ladies and 4 men, I'm going to select two persons. Okay, right. So 4C2 into 4C2. What is 4C2? 4 into 3, 1 into 2. 3 2 times 6. 6 into 6 is what? 36. So totally 36 is the right answer. Okay, next question. In CAT entrance exam paper, there are 3 sections, each contains 5 questions. A candidate has to solve 5 questions, choosing at least one from each section. The number of ways he can choose it. So look at this, there are totally A, B, C, 3. Okay, 3 sections are there. So each section we need to write 5 questions. Correct? Okay. So there is a condition. Only he needed to complete 5 questions. 5 questions is enough. But how to choose the 5 questions? You need to attend at least 1 question from each. So I'm going to put a tabular column. You need to attend at least 1 question from each section. If I write one question in 2 sections, here I need to write 3. The same combination I can interchange, right? 1, 3, 1. 3, 1, 1. So all these, finally I'm going to complete 5 questions. Any other combinations? If I write 2 questions from section A, 2 questions from section B, 1 from section C, now also I got 5. So 2, 1, 2, 1, 2, 2. So this is also the combination, and there is no other combination. If I take any other number, I need to put 0 for any one section. So that is not possible. They need at least one should be right in the section. So how I need to write this? See, out of 5 questions, I'm going to choose 1. So out of 5, I need to write 1. Then out of 5, I need to choose 1. So 5C1. Out of 5, here I need to write 3. So 5C3. This combination was repeated 3 times. Whatever the answer I got from here, it will be repeated 3 times. So don't write again and again. Just put into 3. Plus, what is the another combination? Look at this. Out of 5, I'm going to select 2. So 5C2. Then out of 5, I'm going to select 2. So into 5C2. And out of 5, I'm going to select 1. So into 5C1. This is also going to repeat 3 times. So if you solve this, you will get the answer. Okay, so 5C1 is 5. 5C1 is 5. 5C3 is nothing but 10. Okay, so 5 into 5, 25, 25 into 10, 250, 250 into 3 is 750, right? Plus 5C2 is 10, 5C2 is 10, 5C1 is 5. So 10 into 10, 100, 100 into 5 is 150, sorry, 100 into 5 is 500 into 3, 1500. Okay, if you add, you will get the answer option B. Clear? I hope you guys understand this concept. Right. Next question. 3 boys and 3 girls are to be seated on a round table. In how many ways can it be done so that no 2 boys sit together? Please listen carefully. There are 3 boys and 3 girls are to be seated on a round table. Okay, right. In how many ways can it done so that no 2 boys sit together? If they are speaking about no 2 boys together, we going to seat girls first, because they want boys should not sit together, not about girls. So first seated the girls. Okay, now I'm going to seat the girls first. How many girls are there? 3 girls. If 3 girls going to sit, so let's put 3 chairs wherever they want, they can put it and sit there. But this is a round table. So in circular permutation, what is the formula? N minus 1 factorial. So 3 girls going to seat at first. So 3 minus 1 factorial, that is 2 factorial. This is what answer, 2 factorial. Okay, right 2 factorial. Okay, now I'm going to block the boys. Okay, I'm going to give the seats for boys. How many seats are there? The alternate seats, 1, 2, 3. 3 alternate seats, and I had 3 boys. So 3 P 3. 3 boys can sit in the 3 places. So 2 factorial into 3 factorial. 3 factorial is 6 into 2 is 12. 12 is the right answer. Next one. All the 6 letters of the name Sachin are arranged to form different words without repeating any letter in one word. The words so formed are then arranged as a dictionary. What will be the position of the word Sachin in that sequence? So, Sachin. Now I'm going to write it in alphabetical order. Alphabetical order. So first I need to write A, then C, then H, then I, then N, then S. This is the alphabetical order of all these alphabets in Sachin, right? So first I need to find how many words can be formed starting with A. So number of words starts with A. Okay, so look at this. 1, 2, 3, 4, 5, 6 letter word. First it should starts with A, means how can I write this? 1 P1. I plotted A first. Remaining how many places? 5 places and 5 letters. Apart from A, C, H, I, N, S, 5 letters are there. So 5 factorial. 1 into 5 factorial. 5 factorial is the answer. So likewise, I am going to write number of words starts with next letter C. So C, we had same 5 factorial. So in the place of A, I am going to write C. So first letter is C. Okay, remaining 5 letter 5 place. And next, again, I am going to write for H. First letter should be H. So that is 5 factorial. Then I. First letter I, that is 5 factorial. Then N. First letter should be N. So it will be 5 factorial. Now, the word starts with S. Look at this. Starts with S. So if the letter starts with S, okay, I write S here. Wait, I change the color. Look at this. Now I'm going to start with S. So first of all, okay, so S was placed here. So the remaining letters should be come in the first thing. Okay, so write it in alphabetical order. A, C, H, I, N. This is already in alphabetical order. You no need to change anything. A first come, then C, then H, then I, then N. So if the first word starting with S itself, Sachin. Correct. If anything is interchanged, I need to find that also. but here only S was misplaced. If I write S first, the remaining are already in alphabetical order, and Sachin name also came in the alphabetical order. Okay, so first 120 words, first page starting with A, 120 words are there. Next page starting with C in a dictionary, 120 words. And next page, if I turn out, it was 120 words, then 120 words, then 120 words. When started with S, first name itself, Sachin. So totally 5 120 is 600 plus 1, 601. 601 first word is the Sachin position in the dictionary. Is it clear? Right. How many batting orders are possible for the Indian cricket team if there is a squad of 15 to choose from, such that Sachin Tendulkar is always chosen? Look at this. There are totally 15 players are there. They doesn't say that how many person we need to select, but they clearly says that cricket team. Okay, it was mentioned cricket team means we need to select 11 players. So this is what a common thing. But here there is a condition: Sachin Tendulkar is always chosen. So the competition is not for 15%. The competition is only for 14%. Out of the 15%, Sachin was already selected. So the competition is only for 14%. Out of 14, who is that 10%? But this is not the final answer, because here there is a twist. They also asking one more thing, that is how many batting orders are possible. Batting orders means if 1 2 3 4 5 6 7 8 9 10 11 11 persons are standing. Okay, there are two openers. If they are not played well, these two players are played well, in next match I will interchange them, right? So how many interchanges we can make using this 11 player, that is called batting order, changing the batting order. So totally 11 players and 11th place, right? So I can write 11p11. So answer is 14 minus c, sorry, 11c11. Okay, 14c10 is nothing but 14c4 into 11c11 is nothing but 11 factorial. 14c4 is nothing but 1001 and 11 factorial. So option A is the right answer. Next question. How many motor vehicle registration number plates can be formed with the digits 1, 2, 3, 4, 5, no digits being repeated, if it is given that the registration number can have 1 to 5 digits? See, here there are totally 5 numbers, 1, 2, 3, 4 and 5. You can use this 5 digits and make a number plate. Okay, 1 2 3 4 5, but don't use more than 5 numbers. From 1 to 5 only you need to use. So I had 5 possibilities. Okay, but there is one more thing. You can have 1 to 5 digits. There is one more option, advantage is given, that is you can use one. See, you in the whole number plate you can use 1 digit. Okay, or if you want you can make 2 digit or 3 digit or 4 digit or 5 digit, that is your choice. Okay, so I can use all the 5 and make, how many possibilities is are there for 5 numbers? 5 place. If I make a 5 digit number for my number plate, 5 place 5 numbers, so 5p5. Okay, or this is not and. Okay, if I want 4 digit number, so out of this 5 I can make 4 digit number. How many possibilities are there? Or if I want 3 digit number, 5p3, or if I want 2 digit number, 5p2. If I make 1 digit, only 1 digit means there is a 5 numbers are there. Out of this 5 you can make any one. Okay, so this is what the concept. 5p5 is what? 5p5 is nothing but 5 factorial. 5 factorial is 120. And 5p4 is what? That means 5 into 4 into 3 into 2. Correct? Only 4 places, 5 numbers are there. So this is also 120. 5p3 means remove this. So 5 into 4 into 3. 5 4 times. This 20, 20 into 3, 60. Plus 5p2 means only 2 digits. 5 into 4 times is 20 and next one 5. So just add all the numbers. 120, 120, 240, 240 plus 60, 300, 325 is the right answer. Okay. Right, next question. There are 5 boys of McGraw Hill Mindworks and 3 girls of IIM Lucknow. So let's write that first. 5 boys and 3 girls who are sitting together to discuss a management problem at a round table. This is most important. Okay, in how many ways can they sit around the table so that no 2 girls or sit together? This is another thing. So they are talking about girls not to sit together. Then we need to take boys first, seat the boys first. Okay, so in round table there are 5 boys. I'm going to fix 5 boys first. So there is a row. I send all these 5 boys and these 5 boys going to pick their seat first. So let's take first boy, second boy, third, fourth and fifth. 5 boys are seated. This is round table. So n minus 1 factorial is the formula. So 5 minus 1 factorial is nothing but 4 factorial. So first I'm going to write 4 factorial. These all the 5 boys are seated now. Now no 2 girls are sit together. So I'm going to now arrange the chair, empty chairs in between this boys. So these gaps I filled with empty chairs. So how many chairs are there? 1, 2, 3, 4, 5. So totally 5 chairs are there. But how many girls we had? Only 3 girls. Now I'm going to open the door and send all the 3 girls. You can pick whichever place you want. So out of this 5 place, 3 girls can pick any 3. Okay, so what I can write here? 5p3. Correct? So if they sit together, if 2 chairs are empty means I can remove these 2 chairs. So now look at this. These 3 boys are sitting together. No issues. But never 2 girls should sit together. That's what the condition. That is why we are doing like this. So 4 factorial is nothing but 24. 5p3 is what? 5 into 4 into 3. 20, 20 into 3, 60. So 24 into 60 is 1440. That's what the right answer. Next question. From a group of 12 dancers, 5 have to be taken for a stage show. Among them, Radha and Mohan decide either both of them would join or none of them would join. Let 2 persons are here. One is Radha and another one is Mohan. So these 2 are included or these 2 are going to exclude. So this is the 2 conditions here. When I include these 2 guys, what will happen? Totally there are 12 dancers. Okay, if I included him, they are included means, so the competition is not for 12. Out of 12, we're going to select only 5. Okay, so now they are included means only out of 10, I'm going to select 3 because already 2, Radha and Mohan was selected. If they are not selected means both of them neglected. Okay, excluded. That means out of 10, I'm going to select remaining 5. Okay, out of 10 means I excluded the 2. So only 10 members. From 10 members, you can select any 5. Okay, this is the 2 options. Either I need to choose this or I need to choose this. Okay, so 10C3 is what? 10 and 9. 10, 9, 8, 1, 2, 3 plus 10C5 means 10. Oh my god, 10, 9, 8, 7, 6, 1, 2, 3, 4 and 5. So complete this and you will get the answer. What is the right answer? Directly I will choose that. 21. Yeah, 372 is the right answer. Okay, please check this. Either you got 372 or not. Okay, right, next question. How many numbers greater than a million can be formed from the digits? Okay, so million means we need 1, 2, 3, 4, 5, 6, 7 numbers. Okay, 1, 2, 3, 4, 5, 6, 7. It will be a million. So if I start with 0, then what will happen? It is not million, right? So ones, tens, hundreds, thousand, 10,000, lakh and million. So it will be lakh. So don't use 0 here. Apart from 0, you can choose any other number. So 1, 2, 3, 4, 5, 6. Out of 6 number, you can pick any one number. Okay, right. Imagine that if I write 2 here. Now, the remaining how many numbers are there? So the remaining numbers are 5 numbers, but now I can include 0. Correct? Now I can include 0. So this is 1. So again I had 6 numbers. So 6. I plot any one number in this place. So remaining is 5, then 4, then 3, then 2, then 1. See, totally I had 7 numbers. First number 7 should not, 0 should not come. So I had, instead of 1, 2, 3, 0, 4, 2, 3. Instead of the 0, I had 6 numbers. From this 6 number, any one number will be plotted there. So remaining, if I plot this 2, okay, so remaining 1, 2, 3, 4, 5 numbers, but now I can write 0, right? So again I had 6 numbers. If I plot any one number here, remaining I had 5, then 4, then 3, then 2, then 1. So this is what the answer, 6 into 6 factorial. So 6 into 6 factorial is the right answer. Okay, clear? And 23. A person has 4 coins, each of different denominations. What is the number of different sums of money the person can form using one or more coins at a time? So, a person had 4 coins, different denominations. Here in actual sum, they give 1 rupee, 2 rupee, 5 rupee and 10 rupee coins. Okay, but here that was neglected. Anyway, that is not important here. 5 different types of denominations are there. 4 different types of denominations. Okay. So now what is the number of different sums of money the person can form using one or more coins at a time? So out of this 4, he can pick 1 coin, or out of 4 he can pick 2 coin, or out of 4 he can pick 3 coin, or out of 4 he can pick all the 4 coins. Okay, but here, sorry, I need to write this in combination, I think so. I'm going to pick selected, right? Okay, if I write it in combinations. So 4C1 is 4. 4C2 is what? 4 into 3, 1 into 2. 3 2s are 6. Plus 4C3 also 6. Not 6. That is 4. And 4C4 is 1. Yes, this is what right answer. 6, 10, 14, 15. 15 is the right answer. Write this in combination because we are selecting here. Okay, picking the coins. Randomly, if I pick some coins, right? 1 coin or 2 coin. Out of 4, I can pick 1 coin or 2 coin. Okay, this is not arrangement. This is selection. So answer is 15. Next question. How many numbers between is can with the digits? Repetition digits is not allowed. Okay. So here already we had seen this sum, but it was, I think, multiple of 5, but that is not given here. How many numbers between 2000 to 3000? 1, 2, 3, 4 digit number. Okay, formed with the digits. So from 2000 to 3000 means first number should be 2. Okay, so I will write 1P1. 1 digit was placed here. What is the remaining digits? What is the remaining digits? 1, 2, 3, 4, 5, 6, 7. So out of 7 digits, I need to place 3. So 7 into 6 into 5 is the answer. So 7 6 times. 42. 42 into 5 is 210. That's what the right answer. Clear? Next question. How many ways are there to choose 4 cards of different shoots and different values from a deck? Different shoot means we had 4 different types of shoots, that is hearting, diamond, okay, spade and club. So from each one I'm going to select one in different values too. If I select hearting 2 means it should not come 2 again. So out of this 13, each one had 13 cards, but out of this 13 I'm going to select one. Okay, now next one. Out of this 13, if I select a numbered card, that is 2 means that 2 should not pick here. So out of 12, I need to select 1. Okay, then out of 11, those 2 cards I should not select. So the symbol is different, but number, if I select number 2, Don't select number 2 here. I will select number 3. Then 2 and 3 should not selected here. It should be 4 to 9, any other number. Okay, so from 11, I'm going to select 1. And out of 10, I'm going to select 1. So 13, 12, 11 and 10 is the right one. Clear? In how many ways can 12 papers be arranged if the best and the worst paper never come together? Totally there are 12 papers. Okay, one paper is best paper and one is worst. Okay, it never come together. So just find what is if it come together. Okay, so 10 paper plus these two, it will become 1. So 11 paper, 11 factorial. Out of this, okay, the 11th one is we had 2. So 2 factorial. This is for both come together. But they are asking never come together. So from total, if you subtract this togetherness, you will get the never together. So what is the total? 12 papers is the total. So 12 factorial. Out of that, I'm going to subtract 11 factorial into 2 factorial. So that is given here. Out of 12 factorial, 11 factorial into 2. So this is what the answer. Factorial should come here. Or 2 also same. 2 factorial is what? 2 into 1. So we can take 2 also. So that's what the correct one. Clear? Next question. How many odd numbers with distinct digits can be created using the digits? Okay, how many odd numbers with distinct digits can be created using the digits? So first of all, let's create odd numbers should be at the last one. See, you can create one number, one digit, okay, 2 digit, 3 digit number, 4 digit number, 5 digit number and 6 digit number. That is called distinct digits. Okay, so if I need to put a 1 digit number, there is only one place. That means odd number. 1, 3, 5 is the odd number. Out of 3, I will write any one. So 3 is the answer. For 2 digit number, the last place should be odd number. Okay, so out of 3, I will place 1. Okay, if I placed 3 at the last place, means how many remaining digits are there? 1, 2, 3, 4, 5. And out of 5, there is only one place. One place is waiting for 5 numbers. Okay, so what is the value? 3 into 5, that is 15. Here 3, here 15. Okay, next. 3 digit numbers. So last place should be odd number. So out of 3, one number will put here. Okay, so remaining, so overall 1, 2, 3, 4, 5, 6, 6 numbers. One number was placed. So remaining 5 digits are there. We had 2 places. Okay, so 3 into 5 into 4. What is that? 20, 60. Right. And next for 4 digit 1, 2, 3, 4. Last number should be odd number. So out of 3, I'm going to pick 1. Okay, so remaining 5 digits, we had 3 places. Okay, 5P3. So 3 into 5, 4, 3. 3 places. So 60 into 3. 60 into 3 is what? 180. And for 5, 1, 2, 3, 4, 5. 5 places. Last place should be odd number. So place that first. 3P1 into 5P4. So what will happen? One number will be extra. 4, 3 into 2. So 180 into 2 is 360. Right? And last one, 6th digit. So place this first and 5P5. So 3 into n and r is equal n factorial, 5 factorial, 120 into 3. 120 into 3 is nothing but 360. Same. Okay. Now add all these values. 3 plus 15 plus 60 plus 180 plus 360 plus 360. That is nothing but 978 is the right answer. Okay. Right. I hope you guys understand this. In how many different ways can the letters of the word Rajnikant be arranged? Okay. So Look at this. Totally how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 factorial. What is the repetitions here? Or no, A, 1A, 2A. Right? So 2 factorial. J is 1. N, we had 2N. Correct? So 2 factorial. I, we had only 1. K is 1. Then T and H is not. So 10 factorial over 2 factorial into 2 factorial is the right answer. Right. Next question. In how many different ways can the letters of the word detail or be arranged such that the vowels must occupy only the odd position? So odd position means 1, 2, 3, 4, 6 letters. 1, 2, 3, 4, 5, 6 letters. So odd place means 1, 2, 3, 4, 5, 6. 1, 3, 5 is the odd place. Okay. So what are all the vowels here? These 3 are vowels. E, A, I. 3 places are there. 3 vowels are there. So write 3, P, 3. Arrange this first. So remaining even place 3 and consonants are 3. So 3, P, 3. So 3 factorial into 3 factorial. 3 factorial is 6 into 6. 36 is the right answer. Clear? And next question. In how many different ways can the letters of the word spouse be arranged such that the vowels must occupy only the odd position? Okay. How many different ways? Spouse. So the vowels must occupy only the odd position. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. What are the vowels? O, U, E. Okay, odd position. 1, 3, 5. So in these 3 places, I need to plot this 3. So remaining I had how many places? 2, 3 and 4. Sorry. 2, 4 and 6. Okay, this is the even place. Total I had 3 places. So how many letters? S, P, S. So 3 places and 3 letters. But here S came 2 times. So 2 factorial. So same answer. 36 divided by 2. That is nothing but 18 is the right answer. Next question. In how many ways can 6 boys be allotted into 5 rooms such that no room is empty and all 6 boys are accommodated? So the simple way is 1 boy should be accommodated extra. So let's take 5 rooms. A, B, C, D, E. 5 rooms are there. In 1 room, I need to accommodate 2 person, and remaining thing I need to accommodate one person. So all the person will be seated. So out of 6, I need to accommodate, select any 2. Out of the 6 person, select any 2 boys. Put it in the 1 room. Okay. So totally how many rooms are there? 5 rooms. Okay. Now I make this 2 into 1. 1 person. So 1, 2, 3, 4 and this is 1. 1, 2, 3, 4, 5. 5 room, 5 persons. So 5P5. Listen carefully. 2 persons should be in 1 room. Okay. So make them into 2 as a 1. Okay. So totally there are 5 persons, 5 rooms. 5P5. But out of 6, I need to select any 2 person, right? I don't know which 2 is what. Sometimes in alphabets we say that 2 boys, 2 girls sit together. Okay, vowels should be together, consonants should be together. Because here all the 6 are boys. I don't know who is that. So any 2 out of 6, select that and make them into 1. So 6C2 into 5P5 is 5 factorial. 6C2 is 15 into 5 factorial is the answer. Clear? Right, and this is the final question. If the letters of the word CHASM or rearranged into the 5-letter word such that none of the word repeat and the result arranged in ascending order. Okay, as in the dictionary, what is the rank of the CHASM? So first write it in the order. Okay, first we need to write it in the order. Wait a minute. Question is right? Yes. So alphabetical order. First I need to write A, then C, then H, then S and M. So as usual, already we had right for Sachin, right? Same thing. Number of words starts with A. Starts with A. So one first place should be A. So remaining 1, 2, 3, 4. 4 factorial. Correct? 24. So likewise, write it for C, then H, then S and M. And you need to do what? Again, you need to start with C. So just find out answer for this and give your answer. Okay. I am waiting for your answer. I need you guys should give the answer in the comment box for this question. Okay, for this question already I have explained this using Sachin. Okay, so for this question, please try and give your answer. If you don't know, I will explain it in the next video. Okay, so I hope you guys, out of these 32 questions, you know all everything, all the concepts. And yesterday also we had completed nearly 30 questions. So it's help you to learn more about permutation and combination. So all the very best. Meet you in the next video. Thank you. Take care and bye bye.